Welcome to lesson 1.1.2. I am starting out with one of my little questions here, and you are going to let me know what you think the answer is by the end of the video. So just take a look and tell me if you think negative 9 squared equals 81. We'll talk about it at the end of the video. Thanks. Hi, so this is lesson 1.1.2, and it's not going to take very long. In class, teachers would be having students break up into groups and discuss each one of these equations and then present those equations and the interesting things that they found. We're just going to go through each of the equations pretty quickly and show you a few things, but I won't show them on everything. You're going to start to see a pattern. Then at the very end of the video, we'll show you an image of all of them combined so we can kind of look at any patterns that we see in the numbers. So the first equation I have here is y equals 2 times the square root of 9 minus x, and then minus 4 outside the radical. So what I'm going to do is I'm just going to go ahead and highlight these. This is the Desmos tool that is given in the textbook, so you can also play with it. I've added a few things like a slider to it to show you the vertical line test. And I've also added a table of values for all of the different ones that I found specific points for. So I'm also going to take this. Let's see if I can get this to where it's, there we go. I prefer that so that you can actually see the grids in the one for each point. So it lines up integer wise. Okay, so I have a few points here. So I see that at 9 for x, I have a point. 9 minus 9 is okay. I will have a square root of 0 if I'm plugging that in. The problem is I couldn't put 10 in. If I put 10 in, I would have 9 minus 10 under the radical, and that would give us an imaginary number. And we are dealing with all real numbers, not imaginary. So I can't do that. But then I also have this slider that will come in here and show you. I've been talking about the vertical line test on multiple videos. And if a vertical line test is drawn through a graph and it only hits that graph at one point, it is a function. If it doesn't, it is not a function. So if it was a circle, you would not have a function. But this one is like half of a parabola. So I could take my vertical line and go through the graph, just like I'm doing right here, and that shows you that it's a function. But if I wanted that to continue around and down like this, I would have to use a different equation. And that would look something like this. Let's just go ahead and add another line in. So it's y equals, and then I'm going to say negative 2 times the square root of 9 minus x. And then I'm going to take it outside of the radical and do a minus 4. And then I'm going to graph it. Oh, wait, I'm doing something wrong here. Oh, there. I didn't put an equal sign. There we go. Okay. So as you can see here, I've got this graph that kind of goes around down here. Now, if I was checking this is also known as a conic, which you won't be worried about for right now. But if I was checking this for a function, I would come over here and I would run my slider. And if I drew all of that at once, I would know I didn't have a function. So that would also indicate that the y term has been squared if you've got a graph where it shows it like this. So we can only draw one of those. So I'm going to go ahead and delete the second graph. And that kind of talks about it. But I also have found the integer points that you needed. And again, we talked about some y values and x values that don't make sense. And we'll move on to the second equation. Before I move on to some different equations, I also want to make sure that when you're entering this into a graphing calculator, if I go back and I take this and I just put minus 4, if you notice here, the radical is over the top of it. Notice what that does to my graph. You want to make sure that that minus 4 is outside of the radical. So you've got to hit your cursor over and then put it on the outside, and then you have the correct graph. And a lot of times the errors that you make in Algebra 2 in graphing and using the calculator are just simple entry area errors. So it's always good to try it a couple different times and make sure that your equations are correct and that they're entered correct. So just if something doesn't make sense, a lot of times it has to do with the way you've entered your information. And then also, I think that pretty much covers that. But this is also, if you're talking about domain values, well, our highest x value would be at 9. And then it goes all the way to the negative infinity. So from negative infinity to 9, we have x values. For y values, we start at a negative 4, and we go all the way up to positive infinity. So there are some domain and range restrictions on this particular problem, and you will find those on all of these. So let's move to the second problem. Okay, so you will see here that I have done y equals the square root of 100 minus x squared. And you'll also see it looks like half of a circle. This is similar to the equation we just used, but you'll see my integer points that I found, negative 10, 0, 10, 0, 6, 8, negative 6, 8, 0, and 10. Those are all the integer ones that I found. You will also see at this point with the slider that this is a function, okay? And you'll also notice that I am not going past 10. If I did 10 squared here or negative 10 squared, I would have a 0. But I couldn't put, let's say, a negative 12 squared because that would be 144. We would have a square root of a negative 44, and that's the same if I used a positive 12. So you'll see that your domain is limited from negative 10 to 10. Your range is from 0 to positive 10. Now, just to show you an example of a full circle, I would have, and this means the y term was squared, and it was solved for y, but you can't list them as a squared term because you can only do that with the x value. So if I'm going to take that square root and I'm going to say, oops, I got to put a negative in front of it. Let's do that first. So negative, and then the square root of 100 minus x squared, you will see a graph that looks like a circle. And if I was using my slider, see if I went through there, this is not a function. And so therefore, that's why you can't list a circle as a function, because we have two x values. So if you look at this negative 6, it goes up to 8 and down to negative 8. You have a 0, 10, and you have a 0, negative 10, because we have one x value that shares two different y values. That's not possible. It's not a function. So we're just going to go get rid of that. And that is the discussion for that next problem. So let's move on. So for the rest of these, I'll probably go through them pretty quickly, but let's just go ahead and highlight the graph. Let's talk about, there's the integer points that we have. You'll see that I've got that moved around. I've got my slider, so I'm going to go up here and get it. And we're going to slide it back all the way through the graph as far as we have drawn it. All right, and you'll notice that your y range, the lowest y value here is a negative 6. And then the positive, it goes on to infinity, positive infinity. Your domain is negative 4 to positive infinity. So it's kind of interesting. It's a little confusing when you're looking at the graph, but your negative 4 is the lowest x value and your negative 6 is your lowest y value. As you see, I got that point here. Now, if I was to put a different value into this equation, again, if I put a negative 5 squared in, I would have a 100, oh, that would actually work. Negative 5 works, I'm sorry. If I put in, okay, I screwed up here, so 745, change it over because I was talking about a different problem. Okay, on this one, if I put a negative 5 in, I'm going to have a negative 5 plus 4, and it's going to give me the square root of a negative 1. That is not going to work. So that kind of gives you an idea of some of the limitations again. Again, this is similar to another problem we've already done, so we're going to stop and move on. Here is another square root function with the points aligned, and we're going to go over here a little bit. I want to go get my slider so I can use it. I always forget where it is, line 19. And you can see the points that I have plotted for this particular graph. You can see that it is a function. And let's go down and look at that equation again. Again, I can have a 4 in there because 4 minus 4 is 0. I can't have a 5. 4 minus 5 would give me a negative 1. So our domain on this one is a positive 4, so negative infinity to a positive 4. Our range is a negative 3 to positive infinity. So that's the values for that one, and we've shown it's a function. So now we're going to move on. This particular equation is like half of an ellipse, so it's kind of an interesting equation. But if you see what we've got here, I will go ahead and get the slider, which I've already told you is on line 19. This one's a function, but if we had the other half of the ellipse, we definitely would not have a function. But if we come down and look at the points, we can have a negative 5 in there because that was going to be a 0. But if I put a negative 6 in, we're going to have an imaginary number again. And that's the same thing with if I put a 6 in there. You've got the plus 8, so you have the movement up 8. So that's a vertical, that affects it vertically. So there are your 5 points that I found also on the graph. Okay, so that covers that particular graph. Let's move on. This one's a little different because it's going in a different direction, but it has the same idea. I can go to 9, or negative 9, I'm sorry, and negative 9 plus 9 is 0, so that's the square root of 0, which is possible. But I couldn't go to negative 10 because it would give me the square root of negative 1 underneath. You notice here that the domain is from negative 9 to positive infinity. And you notice that the range is from a positive 4 to a negative infinity. And then it also passes the vertical line test. If I come up here and get it, you've got the vertical line test going through it. So there's that one. On to the next. Here is what looks like the other half of the ellipse that I was talking about earlier. It's a little bit different. Again, it looks like it's translated down 1, so that's interesting. That's why it's at negative 1. But negative 5, again, will give us a 0 under the radical, and that's okay. And a positive 5 will as well, but the information on the outside of that, negative 6 and positive 6 on, are not going to work. So if I'm looking at this one, which I didn't touch so much on domain and range for the last one that looked like this, but the domain on this one is very specific. It goes from negative 5 to 5. The range on this is from negative 1 to 10. So you do have a specific set of numbers. We don't go to infinity in either direction with this particular graph. This will also pass the vertical line test. I will not be going to get that, but you can tell it will pass the vertical line test. All right, let's move on to the next equation. This is our last equation, and you can tell also that it would pass the vertical line test, so I won't be going up to line 19 to get it because you, I'm sure at this point, trust me. But this is another one. If I'm talking about domain, look at this. The highest x value is a positive 4. If I went to 5, I'd get 4 minus 5 again, which would give me the square root of a negative 1, and we're doing only real numbers here. We're not using imaginary numbers at this point. So your domain would be negative infinity to a positive 4. Your range would be a negative 1 to positive infinity because your lowest y value is a negative 1 here. And here are the points that I have plotted for that one. So that gives you the perspective on those 8 problems. And now I'm going to go and show you what they all look like together to look at some patterns. Hang on just a moment. So now what I want to do is I just want to briefly go over some things that you may notice, some similarities that some of these graphs have with each other. If you look over here, so, oops, I don't want to do that. Okay. Let's look at the half ellipses first. I want you to look at this one. Notice there's a negative in front of this. These are the half ellipses. This is a half circle. There's some of the same properties though. You have a negative in front, so this one is opening upwards. But look where it ends. It ends at 8 on both of those. So those are some similarities with this. And you'll notice that because of the x squared in there, you're going to have rounder pieces of graph, and it's going to be upside down and right side up depending on how you look at it. But the negative makes it so this one opens up. Sorry about that. And this one makes it so that it opens down. So you've got a positive here that opens down. Now, if I go over here to the circle, half a circle I should say, this again, notice how there's a positive here and it opens downward. The positive is here and opens downward, but it's on the x-axis because there is nothing on the outside of the equation. Now, if we go look at the square root functions, everything that's positive is opening up to either negative infinity or positive infinity, depending on where it actually is, what direction it's going in. And that has a little to do with the 9 minus x and the x plus 4. But look at here. This is at negative 4. Look at this one. This is down at negative 6. This one is down at negative 3. This is at a positive 4. This is at a negative 1. So this number out here is impacting these equations vertically. It's about vertical shifts of the parent function. So that is pretty much it. I was going to look and see if there was anything else I wanted to say about that. Oh, yes. You also have all of these are opening. They're like the top half of a horizontal parabola, okay, because they're positive. Notice that they have a positive coefficient out front. Well, this would have a positive one as well, but we'd call it 1 just because there's no number there. But this is negative, so this is the only one that is like the bottom half of a horizontal parabola. So hopefully this is helpful in looking at these and seeing what kind of patterns they have. And then you can go back and look at the video too for the rest of the 8 equations. But that ends lesson 1.1.2. Thanks. So to end the lesson, Is it true that -9 squared equals 81? Or is it false? It is false. To make it true, you have to put parentheses around the -9. The reason it is false is order of operations. So we would have -9 squared. And then that means we would have to take the -9 or the 9 squared first because of exponents, because of PEMDAS, if you remember. Okay, so that means exponents would be first, so we would have a -81, because then the last thing you would do is put the subtraction on it. So putting parentheses on it, like I just did, makes it true. But the original statement was false. So either you got it correct or nope. Go have some coffee. This is a corny slide. But anyway, that is the answer for that little riddle at the beginning, or true, false, or yes, no, or whatever you want to call it. Have a good one. Take care. Bye.